All right, we have 6 more problems, so let's get going. All right, so number 16 is one of those questions where you are to sketch the graph of a function with certain properties. All right, if you read the problem, and it's number 16, it says f has to be defined on the closed interval from -5 to 5. Now, by the way, what does it mean when I say closed interval and defined on that closed interval? That means that the function has to have a value, a unique value, f of x, for every x between -5 and +5, including those endpoints, right? And only one point y for each x in that interval. And it also, the problem says that the function has to satisfy all of the properties. So we have to draw one function, or the graph of one function that satisfies the following. The derivative exists. Well, actually, the problem says f is differentiable everywhere on -5 to 5. That's an open interval, technically, because usually we don't talk about the differentiability at endpoints, because the limits are just one-sided. But anyway, so that means it is differentiable on this open interval, except at 0. The second property says f prime has to be greater than 0, which means f prime is increasing on the interval from 0 to 5. And by the way, this clearly means that f has to be increasing on that interval from 0 to 5. Let's say 1, 2, 3, 4, 5. 1, 2, 3, 4. All right, so I have to graph something so that the graph will cover everything from -5 to +5, right? Number 3 is kind of an important thing. It gives an anchor because f of 0 has to be equal to 0. So that gives you 1 point. Maybe I will draw my graph in red. All right, so this point the origin has to be on this graph. That's from number 3. And then number 4, the last requirement, is that f prime is 0 for all x in the interval from -5 to 0. What in the world does that mean? Well, that means that f has to be horizontal. It has to be flat, constant in this interval. So, I mean, the problem doesn't say f has to be continuous everywhere. But if you want a continuous function, basically, this is the only choice you can make. It has to go from -5 to 0 all along the x-axis so that the derivative is 0 at every point between -5 and 0. Okay, so that's half of the problem. The other half is the second requirement, f prime is positive. F has to be increasing from 0 to 5. Now, how does it increase? We don't know. You can go this way. You can go this way if you want. You can go this way, okay? But it has to be continuous from 0 to 5. It has to be differentiable from 0 to 5, except possibly at 0. It says except 0, so I guess the assumption is that the derivative does not exist at 0, which means it has to be a sharp point, or it could be, something like this. I guess that's okay too, if you want. Right? I'm going to erase that because, I mean, the thing is, we don't know, right? But if you want this to be a continuous function, this was one way to do that, okay? And there is a sharp corner at the origin, which means that the function is not differentiable at 0. So there are other ways to do that as well. You can do this if you want, okay? You can do this if you want. It doesn't matter how the function is increasing, as long as it's increasing from 0 to 5. Okay, so I'll just leave it at that, but there are many other correct answers here. Okay, and by the way, this part here doesn't have to be along the x-axis. If you draw it from here to here, for instance, that's okay too. But I mean, why make it so difficult? So I am graphing something that's continuous, but again, you don't have to. All right, so that's number 16. Okay, let's go to number 17. 17, using implicit differentiation, find the derivative of y is equal to the inverse sine of x. All right, now what this means, okay, this only makes sense if x is between -1 and +1, just because what this says is that the sine of the angle y, see, basically the first statement says y is the angle at which the sine is x. In other words, sine of y has to be x. But see, sine of y is equal to x. This has, for each x, the y could be just zillions and millions and, infinitely many angles, right? Sine of what is 0? Well, there are infinitely many answers. So in order to define the inverse, we have to restrict the domain of this function, which is the range of this function. All right, so what is that? Well, y, the angle has to be between negative pi over 2 and pi over 2 in order for this to make sense, because in this interval, the sine of y is a 1-to-1 function, which means you can define an inverse. All right, so this is the restricted domain for the inverse sine and also the inverse tangent function. The inverse cosine function has another restricted domain, which is from 0 to pi, but that's not what we are concerned about here. All right, so how do I do this? Well, use implicit differentiation. So sine of y becomes cosine of y times the derivative of y, right? That's an application of the chain rule because y is a function of x. X just becomes 1. So if you solve for y prime, it's very simple. It is 1 over cosine of y. You can also write this as a cosecant of, the secant of y if you like, but you don't need to. All right, now this is not quite satisfying because you still have y on the right-hand side. So then we do a little trick. This is called trigonometric substitution. You will learn a lot more about this in Calculus 2. But look, the expression, the relationship between x and y is this first one, given that y is the inverse sine of x, which means sine of the angle y is x. So I'm going to write it this way, because here, remember, the sine of y is the opposite over the hypotenuse, right? So x over 1 would do that. X over 1 is x, so this statement is true. But this proportion means that the adjacent side has to be 1 minus x squared to the negative 1, to the 1/2 power, or the square root of 1 over x squared. All right, well, this picture will give you what cosine of y is. The cosine of y is this divided by that, which is square root of 1 over minus x squared. And there it is. This is your expression for the derivative of the inverse sine function, the arc sine function, which is something you learned, okay? But I mean, this is the way to get to this formula, right? I hope it makes sense. And if you have to derive it on your own using, this implicit differentiation, you can. And this is exactly how you are to do that. All right, number 18. You are given the graph. Well, you're actually not. You're given an equation. X squared cosine y is xy plus 1. Now, the set of all points xy satisfying this equation will be some sort of graph. We don't know. It may look like this. It may look like this. Who knows, right? But the claim is that it goes through 1, 0. And it goes through 1, 0 at some angle. We don't know what it looks like. But we are to, maybe the curve goes like this, and we are supposed to find the line, the tangent line that goes through 1, 0. Now, when I see a question like this, I always want to make sure, because I don't know who wrote the problem. Well, in this case, I wrote the problem. But, like, how do you know that this goes through 1, 0? So I plug in 1, 0, x is 1, y is 0 in this equation. The left-hand side is 1 squared times cosine of 0, which is, of course, 1. It's 1 times 1 is 1. The right-hand side is xy plus 1. That's 1 times 0 plus 1, of course, 1. How do you know? What do you know? They are equal to each other, which means this is indeed on this curve, even though we don't know what the curve looks like. All right. Now, in order to write the equation of the tangent line at 1, 0, I have to know the slope and the point. Well, the point is already given. The slope, dy dx, is what I need to know. That's called y prime, right? Y considered to be the function of x in this situation. So we do the implicit differentiation technique. And so you take the left-hand side. the derivative is the derivative of the first times the second plus first times the derivative of cosine of y. That's negative sine of y, but that's not the only thing. Times, remember, y is considered to be a function of x, so you would have to have y prime. This is exactly what happens at the implicit differentiation method. And then you have xy, that's also a product, so the derivative of the first times the second plus the first times the derivative of the second, that would be y prime. Plus 1 goes away. Okay, notice here, I have y prime negative x squared sine y, and then here it's minus x. I'm going to factor out, y prime. And then on the right-hand side, I have y minus 2x cosine y. That's right here. Okay, so y prime, which is dy dx. Remember, this is the slope of the tangent line because it is basically the the difference quotient, the delta y over delta x when delta x becomes 0. That would be a long expression. It's this whole thing, y minus 2x cosine y divided by negative x squared sine of y minus x. Now, this looks really ugly, but that's okay because we are not concerned about writing this for every point. We just need this thing for 1, 0. Okay, so if you plug in 1, 0, 1 for x and 0 for y, you get 0 minus 2 times 1 times cosine of 0, which is 1. All over, well, let's see, it's negative 1. Sine of 0 is 0 minus 1. So this is negative 2 minus negative 1. That's 2. Okay, now I'm going to move this a little over because I need a little more space to write what I need to do next. Okay, so let's draw a little line here. Oops, I just need just a little more space here. All right, so this is a slope of the tangent line. Okay, so this picture is not accurate. The slope of this line will be 2. Okay, so what happens here? Well, it's going to be the line that goes through 0. Well, sorry, 1, 0, and the slope is 2. So the answer to this question is y minus 0 is equal to the slope times quantity x minus 1. Now, of course, you can rewrite this as y equals 2x minus 2, and that's sort of like the standard slope-intercept form, and that is the answer to that question, what the tangent line equation is. Okay, let's go to number 19. That's the number 19. That was 18, right? And then number 19, the chain rule. Let's do this equation. Let's look at this equation. The natural log of e to the x, that's a composition function. So you take, this is the inside function, e to the x. Ln of the blob becomes 1 over the blob times the derivative of e to the x. That is one of the easiest things now to you, right? What is the derivative of e to the x? And the answer is e to the x. That question and the answer will never, ever change in your lifetime and beyond, okay? So 50 years from now, if somebody asks you what the derivative of e to the x is, you say e to the x. Notice here, they cancel each other, and the answer is 1. And it may be a surprise, like what kind of a function has a derivative 1 constantly? And the answer is it's going to be like x, maybe plus a constant. But that's exactly what this is, because if you look back at this equation, what is the natural log of e to the x? E to the x, I mean, this is the function that exponentiate x by the base of e. The natural log is the inverse of that, right? So e to the x and the natural log of x are inverses of each other. E does the exponentiation. The natural log does the opposite. So the answer in this function was exactly e to the just x itself. So the derivative is, of course, 1. But that's also verified here using the chain rule. And that is cool, right? Okay. The chain rule, that's so cool. The rhymes. Okay, number 20. What is the 13th derivative of the cosine function? So you can do the first 4 or 5, just so you can, sort of do a hands-on and you can see exactly what's going on. The first derivative is negative sine. The second is negative cosine. The third derivative is negative of negative sine, which is the positive sine x. The fourth derivative is cosine. And once you get the same thing, of course, the next ones will follow exactly this. So there will be a cycle of 4 steps, right? Now, the 13th derivative, which you can write this way, as opposed to 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, this is a terrible notation. This is a terrible symbol, right? So don't use this. All right, the 13th derivative is going to be the same as, well, subtract 4 from it. It's going to be the ninth derivative, which is the same as the 5th derivative, which is the same as the first derivative. You don't even have to do this because all you have to do is to figure out what the remainder is when you divide 13 by 4, and the answer is 1. And so it will be equal to the first derivative of f, which is negative sine of x. And so that's all you have to do. You definitely do not want to take the derivative 13 times. The point of this exercise is not to differentiate this 13 times. What happens if it's like 3,013 times, and the answer will still be the same, right? So make sure you see the pattern because pattern recognition is one of the most important things that you learn in mathematics. Okay, finally, number 21. You have this function, and by the way, this last question has to do with the inverse function derivative, which most people really do not like very much. And I don't blame you because I also did not like this when I learned this. Okay, so the problem says this is the function, and I'm going to tell you the problem is, okay, f of 0. If you can plug in 0 here, you obviously get 1. So this function, although we don't know what the graph looks like, is going to go through 0, 1. That's right here, okay? And it's, the thing is the inverse, you're supposed to find the inverse, the derivative of the inverse function. So it's going to have to be denoted this way at 1. Okay, that's what you're supposed to find. All right. Well, the derivative we don't even have the derivative, and so if you look at the statement of the theorem that has to do with the inverse function, it says something like this: the inverse function, the derivative of the inverse function at a point, A, is going to be 1 over the derivative of something. Okay, and then what is this something here? And then it'll tell you that it's going to be the inverse of A or something. Okay, this is a really hard thing to understand. Okay, so my suggestion is you learn this by picture. Right, so this f of x, we don't know what it looks like, but I bet the graph is going to be something like this. Okay, something like that. What does it mean? Well, I don't know, but it's a one-to-one function because the inverse obviously exists. All right, and it says, and by the way, if you take the derivative here, it's 7x to the 6 plus 2. So the derivative at 0 is going to be 2. And that means the slope of this line, the tangent, is going to be 2. Okay, it doesn't look like 2 here, but that's okay. And so that's what we know. Oops. M is equal to 2 here. Okay. Now, I think from this, you can pretty much see that if, the inverse is going to go through this corresponding point. If this point is 0, 1, which it is, then the inverse, where you switch x and y, of course, has to go through 1, 0. And also, there is the graph of this function is going to be a mirror image. And so the graph will be something like this. Okay, tilt your head by 45 degrees. And then you will see that this line is symmetric. So this is f, and this is f inverse. All right, and the question is, what is the slope here? Well, you can tell because x and y are switched, dy dx over here was 2. So basically, this will be dx dy, the opposite or the inverse of that. So the answer, I think from the picture, you can see the inverse has the derivative, which is at x is equal to 1, has to be the reciprocal or the inverse of that function. That's 1/2. Okay, and that's all this is saying. It's if you have to find the derivative of the inverse of f at some point, okay, some point, like in this case, a, and a stands for 1, find its inverse image. What is the inverse image of 1? You know, f of what is equal to 1? And we know the answer, f of 0, right? So this is 0 is the inverse image of 1. That's what this whole thing is. Not that. It's this whole thing is. And so even though the statement is very difficult to understand, I think what you want to do is to draw a picture like this. And you say, all right, if the slope here of the tangent line is 2, the slope here of the tangent line of f inverse at that corresponding point has to be 1 over that, slope, which in this case will be, because the original function has a slope of 2, then the point has the slope of 1/2. All right, so the answer here is that the inverse function, f inverse, has the derivative at 1, which is 1/2. Okay, so that concludes this practice test number 2. All right, I hope you do well, and I hope you have, I may have been cut off, but have a wonderful day anyway.